look at number 1, the graph shown, our represented polynomial, we're going to use it to answer the following question. So if we take a look at A, it says state the relative maximum and minimum. And again, we've talked about this way back at the beginning of the year. So the relative maximum or minimums are just, in other words, your turning points. Okay? So relative maximums are just the turning points that are high points. So what's one of those? Perfect, negative 32. That is a turning point, and it is a maximum. What's another one? 2? 2, 1. Very good. 2, 1 is another relative maximum. And there's no other ones. If we look at, say, all the relative minimums, those are just all the low turning points. So what is a low turning point on the graph? Megan? Very good. -1, -3. What's another minimum? 8? 4, -1. Perfect. 4, -1. The absolute maximum and the absolute minimum are just whatever the highest point is and just whatever the lowest point is. It doesn't necessarily have to be a turning point. In this case it is, but it's just your highest point and your lowest point. If we look, what's the highest point on this graph? And what is the lowest point on this graph? For D, says what is the least degree of the polynomial? Meaning it's just asking what's the degree. And to figure that out, all you have to do is how many turning points are there? 4. There's 4. So what did we say the relationship was between the degree and the number of turning points? Yes, the turning points is 1 less. So there's 4 turning points, just add 1. What's the degree? 5. And the reason why it says least degree is because technically that could be a 6th degree polynomial or a 7th. It could be bigger because it has a bunch of unique roots. But in this case, just think, count however many turning points there are, and then add 1. And that would be the least degree of this polynomial. For E, it says, is the leading coefficient positive or negative? How can you tell? Think about the arrows. How are the arrows pointing? What is it? Yeah, it's negative. Very good. It's nope. Sorry, flip-flop it. It's positive. Odd ones are backwards because if it's positive, it starts pointing down and it ends pointing up. For odd degree polynomials. Odd degree polynomials, if it's negative, it starts up and it ends down. And backwards is what even would be. This one would be positive. Okay. And again, we can tell by the arrows. The end behavior tells us. Just look at the arrow, see where they're pointing, and it will tell you whether it's positive or negative. So a positive and even function, arrows will be pointing up on both ends. Negative and even, arrows will be pointing down on both ends. Positive and odd, down on the left, up on the right. Negative and odd, up on the left, down on the right. And really it's helpful having the graph or graphing your calculator kind of helps you out too. Over what interval is the function increasing? We take a little text bubble over here.
We have to include the staff. At this time, we are going to.
Again, we were talking about this speech bubble before the drill. So think about increasing and decreasing in this way. Over what intervals are of the x are the y's increasing and decreasing? So over what x values is the graph going up, and over what x values is the graph going down? That's essentially what we're asking for, decreasing and increasing. So the numbers we're writing down are x values, but we're looking at how the y is changing. So always read these from left to right. Start on the left part of our graph and follow. Are we increasing there or decreasing? Yes, we're starting left, we're going down to up. We're going up, that means we're increasing. So whenever you start on the left side of the graph and there's an arrow, remember we're talking about in relation to x values, the left part of our graph, if we go on forever, is what? Negative infinity. So we're starting at negative infinity, and where do we stop increasing at? What x value? Negative 3. Let's go find the next increasing interval. Here. Here we're going from down to up. So over what x values there are we increasing? Where we start increasing again?
Negative 1.
Good. And where do we stop increasing at? 2. And then we have another one where we're going up from a low point to a high point. Low to high. Right there we're increasing. What x value do we start increasing at? 4. And where do we stop increasing at? Infinity. Okay. We always put parentheses around our numbers and infinity when we're doing increasing and decreasing, because we're technically not increasing at negative 1. That's just where we start to increase. Okay? We're not increasing at positive 2. That's where we stop increasing. Everything in between those, we are increasing. There's not included. So we want to put parentheses. Okay. So we're going to find the intervals over when we're decreasing. So here, circle. Decrease is when you go from a high point to a low point. So here's where we are decreasing. At what x value are we decreasing at? Good. And where do we stop decreasing? Negative 1. So negative 3 to negative 1. 2. Here's our next section, 2 to 4. Oh, sorry. There's where we are decreasing again. We're going from a high point to a low point. So where do we start decreasing at? 2. And where do we stop decreasing? 2 to 4. We are decreasing. Questions over that? Here we're going to state the domain and range of the functions for any of these polynomial functions. If there's arrows at the end, or just assume there's arrows at the end, it's always going to be what? For the domain. Yeah, negative infinity to positive infinity. Always going to be in the domain with these polynomial functions. Right? The range is what's going to be different. Right? If your arrows are pointing in opposite directions, so this arrow is pointing down towards what? Negative infinity, and this arrow is pointing up towards positive infinity. So if they're in opposite directions, it's always going to be negative infinity to positive infinity, no matter what. Doesn't matter if the first arrow is pointing up and the second arrow is pointing down. If they're in opposite directions, it's always going to be negative infinity to positive infinity for the range, no matter what. No matter how the turning points, which arrow's up, which arrow's down, as long as they're opposite, it's always going to be negative infinity to positive infinity. When they are pointing, both pointing up or both pointing down, that's where the range changes a little bit, and we'll see that on the back. And the last thing, end behavior, say the end behavior of this function. So again, when it has x towards negative infinity, that just means the left side of your graph. So if we go to the left side of our graph, where is it pointing? Down to negative infinity. And then the positive infinity just means the right side of our graph. So we go to the right side of our graph. Where's it pointing? Up towards positive infinity. There's no questions over there. Okay, flip it over. Look at the back. Here we were given an actual function, but we can still analyze and answer questions without graphing it. What's the degree of this polynomial? Think back to what we did yesterday. What is it? Perfect. It's 4. How did you get 4, Josh? Yeah. Very good. When it's in this factored form, we know it's in factored form because there's parentheses. You just add up all the powers. And if there's nothing on the outside, it's just 1. Just as Josh said, 2 plus 1 plus 1 is 4. Is the leading coefficient positive or negative? Yeah, negative. The number out in front is negative 0.1. It's negative. That's your leading coefficient. Whatever the number out in front is, or the sign right out in front. What's the maximum number of turning points if our degree is 4? What is it? 3. Always one less than your degree. So the maximum is 3. And the end behavior. Okay? The end behavior. Think about the degree. So degree odd or even? Even. And is it positive or negative? You said it was negative. So if it's negative and even, that means the arrows are pointing in both directions. But which direction are they pointing? It's negative. Yeah, they're pointing down. So both arrows are pointing down. That means both y's are going to be pointing towards negative infinity. They're both pointing down. That's how you can do it without using your calculator. If you have a question like this, that can have on your quiz, you have one on your test, just graph the function in your calculator, y equals, graph it, and then look at the end behavior that way. That's how you can figure it out without even looking at the picture. Okay? Again, you can always just graph it and look at your end behavior if you need to. For E, it says find the x-intercepts of the graph, state their multiplicity, and how they behave at each x-axis. So that means each of these parts, each of these factors, you're just going to solve. Set them equal to 0 and solve just as if we factored it. So here, when we take negative 0.1x squared and solve, what do we end up getting? Divide by negative 0.1. 0 divided by anything is 0. Square root both sides. X is equal to what? 0. So no matter what, if you have an x squared, an x cubed, an x to a 4, 5x squared, doesn't matter. If it's just an x and you're not adding or subtracting anything to it, that x-intercept is always going to be, or that root is always going to be 0. So if you have something like this, like the green one, that's always going to be 0, no matter what. If it's just an x and you're not adding or subtracting anything. Okay? Well, what's the multiplicity of 0? 2. You have the exponent was 2. So if it's 2, is it going to cross or touch? Touch. If it's even, touches. And then what's the behavior? Linear, quadratic, or cubic? Quadratic. And whatever the multiplicity is, that's the power it's going to be. So if it's a 2, it's quadratic. Quadratic or squared. Alright. We'll solve this next one. X plus 3 equals 0. When we solve that, what do we get? Negative 3. Just change the sign. Shortcut. What's its multiplicity? 1. So again, that's the exponent that's on the outside is 1. So if it's 1, is it going to cross or touch? Odd multiplicities cross. And is it linear, quadratic, or cubic? Linear. And then solve the next one. X minus 4. When we solve it, we get what? 4. What's its multiplicity? 1. And then since it's 1, it's going to be the same. It's going to what? Cross, and it's going to be linear. Questions over there? First. Okay. Using your graphing calculator, we're going to graph this function. Sketch it below, label the turning points, or around the turning points. And there's 10. So make sure you're practicing this in your calculator. So when it comes time to your test, you know how to do it. So again, to graph it, go to y equals and plug it in. I already did mine. Go to y equals, plug in your calculator. Down. Help with your calculator. As you're typing into y equals, make sure you change the table to match what's in this box. So to change the, change the window, you're going to hit window. And change your x min, x max and y min, y max and your scales to what's in the box. So once you plug it in y equals, hit window, and change your window to what's in the box. If you help with that, let me know. Plug in the y equals. Change the window. The graph. You're missing pictures. You got your x with them. Okay. And then hit graph. So it looks something like that. If you're not getting something like that, make sure you raise your hand. Oh, go back to 0. Make sure when it's a negative, you use the negative button. So it reads it as subtraction and then it gets confused because you're not actually subtracting anything. Yes. Oh, you forgot your x with the negative 0.1. That's right. Okay. So then your graph will look something like this, and then you're going to sketch it on this grid. When you do that, plot your zeros. Put points for them, because that's what these where it's crossing on your x-axis. So we're going to put a point at 0. We're going to put a point at negative 3. We're going to put a point at 4. And then you just connect with that same kind of curve. So something along those lines. It doesn't need to be perfect. Like a squiggle. It doesn't. Then once you've graphed it, you need to find the turning points. So to find the turning points in your calculator, you're going to hit second, trace, and this first turning point, is that a maximum or a minimum? It's a maximum. So what do you think we're going to hit? Maximum. So arrow down maximum, just hit 4. Oh boy. All the way over. Find that first turning point, and it says left bound. So that means you're just going to arrow over. So you're a little bit left of where you think the turning point is, and hit enter. Right bound, you're just going to arrow over. So you're the right of where you think the turning point is. Not too much though. Hit enter. And then the gaps, you just go in between where those arrows are, or where you think the turning point is, and hit enter. Should you get about that? That's okay. Sometimes we get decimals. So then that's what we're going to label. So we're going to label it negative 2.1 and 2.4. That is our first turning point. Is this turning point really obvious without having to use our calculator? What's this turning point? 0, 0. If you're like you can't tell, because that's where it's coming down, it's touching it at that axis, it's touching it at 0, that's one of our roots. You can just tell by looking at 0, 0. If not, just use your calculator. Double check. Okay? So then we're going to find that other maximum. So again, what do we press? Trace. And then it's a maximum, so you do second, trace, 4. The arrows are left bound, just means to the left. Right bound means to the right. So we'll go a little bit left. Where you think it is. Enter. And then arrow a little bit to the right. Enter. And, oh boy. That's a little long. And guess. That's about that. So that is the other turning point. 2.9 and 5.5. So those are the turning points. So we said this one was 0, 0. And down here. We can use these turning points to help us find where it's increasing and decreasing in the domain and range. So again, increasing is where you're going from a low point to a high point. Low to high, so here we go. Where are we starting from when we start increasing here? I think it's the left side of the graph. So we're going to start at negative infinity. And where do we stop increasing at? Yeah, negative 2.1. And we're always talking about the x values. So then here, we're increasing again, and we're starting where? And we stop at 2.9. Those are all of our increasing. Now we're going to take a look at where we're decreasing. We're going from a high point to a low point, which is right here. What x value do we start decreasing at? Good, negative 2.1. And where do we stop decreasing? Perfect. And then here again, this is the tricky one. So where do we start decreasing? 2.9. Where do we stop decreasing? So super tempting to say that because it's pointing down, right? You're thinking negative infinity. But remember, when we write it, we're writing in relation to the x values. So if we're on the right side of our graph, which infinity is that representing? Positive infinity. That's why this is super tricky, because our brains are telling us, oh, it's pointing down, it's negative. So it's like a natural thing to think. So you have to remember, we're talking in relation to the x value. So here it's 2.9. We're not done. And it's opening up wider to positive infinity in relation to the x. So that's positive infinity. Now, what did we say the domain is always with these polynomial functions? Yeah, negative infinity to positive infinity. And then the range, are arrows pointing in the same direction or opposite direction? Same. So it's not going to be negative infinity to positive infinity. Okay? Where are arrows pointing? Negative infinity, because we're talking about y. So pointing down towards negative infinity. Perfect. And then your highest y value, so the y value it stops at is 5.5. It's this point right there. We put a parenthesis around infinity, put a bracket around 5.5. Completed. Any questions over that?